Hello YouTube, Swordsman Gaming here, coming to you with the second episode in our cosmic quest. Today we are going to be delivering Jebediah Kerman safely into orbit and returning him back. And I'm going to teach you how to do it. So you might recall from the last episode we acquired these thrust gimbaling engines that had the ability to move. And that makes it much easier to get into orbit. So you're definitely going to need those, and you can see I have 5 of them, and that's just to get all of this up into orbit. So the bottom stage is going to be our suborbital stage. It's going to get us up into the higher atmosphere, and then we're going to get to our apoapse, and we're going to fire our second engine in the smaller stage, and that's what's actually going to get us into orbit. Let's hit the T key, throttle all the way up, and press the space bar, and we begin climbing. So you can see these clouds of what appears to be like dust and smoke coming out of the sides here. That is a real-life system that they use for rocket launches, where the thrust, the exhaust from the rocket motor, hits this, what's essentially a divider, and it throws it out and out of the way of the rocket, so that way it doesn't bounce back up and damage the engine. Because you can imagine, a rocket is very expensive, and to have to replace it would cost a lot of money. Alright, we're about kilometer and almost 2 kilometers up right now, and still going. We're now going, like I said, 200 meters a second and increasing, so I'm going to throttle back a little. Since we don't have any cones right here, this isn't very aerodynamically stable, so if we were to go past the speed of sound, we would most likely experience some serious control issues. So we don't want to go much faster than 300, which is why I'm throttling back. Once we get up past 8 kilometers, I'm going to throttle all the way back up again. As we get higher, you can start to see the curvature of Kerman. There also is a mysterious airfield over there. Maybe we'll visit that in future episodes. Alright, we're at 9.5 kilometers. That's close enough. I'm going to hit the Z key and throttle all the way up. So now we are exceeding the speed of sound. But however, since we're high up, there's not a lot of air, which means there's no air to push through, so it doesn't matter how fast we're going. You can also see in the distance the moon. It's a lot more clear since we don't have to look at it from the surface. In fact, if you were to look at the moon from the surface of the Earth, it would look different than if you were, say, on the space station, because the curvature of the atmosphere almost acts as a carnival mirror, and it reflects light in a certain way. So the moon doesn't look as it does here on Earth. It looks very different the higher you get. Alright, we are approaching 25 kilometers in height, and if we look, our apoapse is approaching 85 kilometers, so I'm going to hit the X key and cut our thrusters. We're almost at 100 kilometers right now. So here's how you get in the orbit. You want to start traveling horizontally now, because if you kept going, you would eventually escape the sphere of influence of Kerman, and you would just go into an orbit around the sun. But there isn't much science to gain from a random orbit around the sun. So you want to get into orbit around Kerman, or Kerbin. I keep calling it Kerman. You do that by firing along the prograde marker. The prograde marker has these 3 little dashes coming off of it that look like an airplane. You want to start throttling up and coming over. You'll see our orbit is starting to look more round. It's starting to flatten out. That's the prograde marker, by the way. So right now, we are horizontal relative to the surface of Kerbin. And if we come out of the map view, you can see that. We are actually horizontal. Let's throttle up. So right now we're gaining horizontal velocity. We need to be going fast enough that the gravity of Kerbin does not pull us back in. Alright, we've run out of fuel. So, we're going to jettison this stage. As so. And this stage is going to fall back into the atmosphere. It's going to burn up and never be seen again. Well, this stage is what's going to get us into orbit. We don't have a lot of fuel, but since we're out of the atmosphere and there's no air resistance, that doesn't matter. So if you want to do this the efficient way, you want to create a maneuver node. And by doing that, you click add maneuver, and you have these markers. And this marker right here on the right is the prograde marker. This is the retrograde marker. You're going to want to pay attention to the prograde marker. And what you do is you drag it out. That dotted line that you see is your orbit after this maneuver has taken place. So you keep dragging it out until you get a periapse on the opposite side. The periapse, if we were to complete this maneuver, would be 63,000 meters. That's not high enough because our apoapse is 124,000 meters, so we would need to keep going. Pull it out a little more. You see when the periapse comes over here and the apoapse goes to the other side, you know you're getting close. 118, 129, maybe a little more. 120, 130. That's good enough. So then you have to line your nose of your spacecraft along that blue marker, and we need to accelerate. It's telling us we need to be accelerating 1,163 meters a second, and in order to achieve an orbit. So what you do is it says the node is in 45 seconds. Once we get about 20 seconds away from having to burn, we're going to fire up our engine. Alright, 20 seconds. So now what you do is you press, well, you have to activate your engine first, and press Z. And now we're throttling up. It says in 30 seconds, the maneuver is going to be complete. You should have enough fuel to do this. Let's go into our map. You can see our orbit is becoming more flat. Right now we're suborbital, but what's going to happen is it's going to elongate itself so that this side right here and this side right here of the blue are going to be touching. About 5 seconds left in the burn. 2, 1. Alright. We're in orbit, and we still have some fuel to spare. So, Jebediah Kerman becomes the first Kerbal ever to be in orbit. And if you look, you can just see the runway of the Kerbal Space Center down there. You can just see it. So if you look over there also, you can see our debris. That's going to fall back in. And if you want to see the debris, you take your mouse, put it at the top of the screen, collect what it kind of looks like a soda can on the far left. You click it, and you should be able to see your debris. It looks like a domino almost. And if you put your mouse on it, you'll see the trajectory of your debris. So our debris is going to be re-entering the atmosphere very soon. If you look, it's losing altitude. It's probably going to enter the atmosphere in like 2 minutes, and if it doesn't burn up completely, it's most likely going to splash down near the coast of this landmass right here. But we're going to keep going. We're in orbit right now. So, first of all, if you made it this far, congrats. And congrats to you, Jebediah. You're the first ever into orbit. But we didn't come into orbit for nothing. We need to collect scientific data so we can get more parts. And you can see the engine, a little wiggle to it right there. I'm just going to do this so that way. So there's a little bit of a bug in the game right now where if your pod is not angled the correct way and you take an EVA report, you can't get back in, which is unfortunate. But they're working on it. So, now that we're in orbit, we can conduct all sorts of scientific experiments, and if you noticed, I have these 2 canisters on the side of the pod. Those are mystery goo canisters, where they basically took some rotten goo from the break room, they threw it in a canister and strapped it to a rocket, and they called it science. So let's take a goo experiment now. Observe the mystery goo. The goo seems to have clumped up into a sphere. It also appears to have become brittle. I wonder what that could mean. Let's keep that data. Alright. So right now we're over the ocean. You'll get different scientific data from being over the ocean or being over the desert. You can even get scientific data from being over the poles. It goes on and on. But let's take a crew report. Let's take the crew report. It seems we are very much in space right now. The sky seems to be mostly below us. Yes, it does. Alright. So, we're going to save this experiment on the right here until later, until we're over the desert. Something to take note of. The sun is there. The sun is going to be setting very soon. You don't want to be caught outside of your spacecraft while you're doing an EVA report. So let's do one really quickly. Actually, before I do, I'm going to prove to you that we're in orbit. I'm going to hit the time acceleration key. And you're going to see us fly around the planet. The first sunrise ever captured from a spacecraft. It's a beautiful sight. Alright. So, now that we have essentially, I guess you could call it a whole space day of light since the sun just rose on the side of the planet, you can conduct an EVA report. But before we do that, I need to spin us upside down. Or right side up. There is no up or down in space. Okay, now that we're pointed, our engine is pointing straight towards the surface. Now, you can hold, there's not just W, S, and D, there's Q and E. You press the Q key to turn to the left. You press the E to turn to the right. We're going to press the E key as for now. We're also going to angle the opening of the spacecraft. You see the little ladder there? We're going to angle it toward the sun. That way, if we get lost, it'll be easy for us to find our way back in. And our Jebediah is going to take the first ever spacewalk. Okay. Here's what we're going to do. You press space to let go. And now you're just floating. Now, to activate your rocket pack, you press the R key. Just like that. And you use the W, A, S, and D keys to move around. You press the D key to move to the right. Press the A key to move to the left. Press the W key to move forward. The S to move back. Use the Q key to spin. Just like that. And I believe... yeah. Right, okay. So, now that you're floating, and we're moving right now at a very fast speed, but since we're both moving at the same speed, it looks like we're just floating. So now that we're outside of our spacecraft, we can conduct an EVA report. So he's gonna record what he's seen. He's recorded the observations about the situation. So you'll remember, the previous situation we were in on the launch pad was boring. Nothing was really happening. Right now we're in space. So that's definitely worth some science. So we're going to keep that. And if you want to, if you're feeling brave, you can just use your rocket to examine your spacecraft. I think I might do that really quick. So, as I mentioned before, this engine right here is a liquid fuel engine. It also has thrust gimbaling, so it can move around, and it makes it a lot easier to maneuver your spacecraft, both in the atmosphere and in space. And that's really important because the SAS systems, which use what is basically flywheels to move your spacecraft around, isn't enough sometimes, and you just need some help from your engines. So, you press, I also don't think I mentioned this, you press the shift key to fly up, you press the control key to fly down. I'm just going to quickly tap it to slow ourselves down. And I'm going to press the W key to fly forward. I'm going to press the control and shift key to make sure we're flying level. I'm going to press the F key to grab on, and then what you do is you press the B key to hop back in. All safe and sound. So, we want to collect, first of all, we want to land in the desert, because the desert has is a special biome, you could say. And it'll give us some new scientific data that we haven't had yet. So here's what you want to do. You don't want to have your orbit fall. I'm going to show you what I mean. You don't want your orbit to be like, you see what I mean? You don't want your orbit to be touching the surface. That's dangerous because you're coming into the atmosphere at too steep of an angle, and the shock heating is what's going to kill you. It's not going to be the force of the impact, it's going to be the shock heating. What you want to have happen is you want your periaps to be at about 30,000 meters. Just about. And actually, hold on, let me think about this. Yeah, so you want your periaps to be at about 30,000 meters. You want to do that because if you come in at too steep of an angle, you're going to get so much shock heating, you could explode. If you come in at too shallow of an angle, you could miss the atmosphere entirely and fly off and back into space. So we're going to use the atmosphere to slow us down. However, right now we're at 32,000 meters. I'm just going to do a quick burn. I'm going to do a quick burn to bring it back down a little. Just like this. Okay, now we're at about 30,000 meters. So we are going to be hitting the upper atmosphere in exactly 13 minutes. 14 minutes, real life. But we don't want to be here for that. That's boring. So what you do is first of all, you want to get rid of this stage. You press the space bar. And we've just separated now. So this is our re-entry vehicle. This little pod. And it's going to land back at Kerbin. This is going to hit the atmosphere and probably crash back into the surface. We are going to use our parachute. So let's start speeding up. We're flying over the continents. And we're starting to fall back into the atmosphere. You can see that we're losing altitude at about a rate of 1 kilometer every 5 seconds. About. So we're going to be coming in. We're not going to hit the desert, I don't think. We're going to overshoot the desert. However, we may get lucky and hit this continent here. However, we're most likely just going to splash down. So let's time accelerate up to the 30,000 meter mark. So, for those of you who don't know what shock heating is, I should probably explain this now. Normally we think of fire as being caused by something that's like been lit on fire. Like a piece of wood is lit on fire because it exceeds a huge temperature. However, you don't need to have a huge temperature to light a fire. It can be done with pressure, because ice can be frozen not because of its temperature but because of pressure. You can freeze water under great pressure, and the same goes for fire. Basically what happens is the air molecules, we're traveling so fast through the atmosphere that the air molecules get almost stuck to it. Like if imagine you're in a race car and you start accelerating very fast, you're pushed back into your seat and you can't really move. The air molecules are pushed back against this heat shield here, and they can't go anywhere, and eventually over time enough air molecules get stuck to the bottom of the heat shield that there's friction, and it basically lights. It looks as it's burning. It lights on fire because of the friction. But if you come in too steep, you're going to be going too fast. There's going to be too much shock heating. If you come in too shallow, there's not going to be enough. You're going to miss the planet entirely. So I think that was a decent explanation of it. Obviously, that's, it's more complicated than it really is, but it does have to do with the air molecules. Alright. So right now we're in the upper atmosphere. We are getting air resistance. We're not going to get shock heating until we get into the lower atmosphere, though. So let's time accelerate until that happens. Also, let's switch our velocity to the surface velocity. Now we're traveling under 40 kilometers. Who knows? We might hit this continent here. I would be surprised if we did. Who knows? We might. That'd be great because we could take a surface sample. Oh, here we are. We're getting some shock heating. So right now we're traveling too fast for the air, getting caught under the heat shield to escape. And since it's being compressed, it's creating friction. And in turn, that is lighting this thing on fire. You can see the heat shield, the bottom of this craft, starting to glow. But we're also slowing down, because since there's a lot of friction, there's a lot of force, there's a lot of pressure, we're using the atmosphere as a brake. And it looks like we might be about to hit these mountains. Maybe we'll fall a little shallow. Oh, so these scientific experiments, since they're on the edge of the spacecraft, they're taking damage because the shield only protects, the craft, and these are on the outside of it, so they're basically bearing the brunt of their own shock heating effects. And I believe that's the Space Center down there. No, that's just a lake. I'm going to turn off my SAS systems. The atmosphere is kind of going to act as is going to keep us pointed in the right direction is what I'm trying to say. So the shock heating is starting to wear off because we've slowed down enough that the air that was originally trapped is being able to escape. That's what, you see, we have a little Mach effect there. It looks like we're going to fall shallow of the mountains by the looks of it. But while we're in free fall, let's take that second scientific experiment. Let's keep that. The goo jiggles and wobbles as the craft flies. Let's keep that. And we'll press the space bar to release our drag chute. And that's going to bring us down over these little baby mountains. Let's time accelerate. The people at the Kerbins at the mission control were shocked to find that Kerbin is not actually flat. They were also shocked to find that they even had a desert. Jeb isn't even scared that he's falling incredibly fast. Jeb is kind of like a, I don't know, he's a badass. That's all he is. He doesn't care if he's in mortal peril at all. Alright. A little hard landing, but we're all good. We're all good. So, now we can hop out of the spacecraft and take a surface sample of this grass. The dirt and grass and some small rocks. You suspect this isn't going to be much of a groundbreaking discovery. On the contrary, sir, this grass is space grass from another planet, probably. I don't know. It's probably just grass. Let's plant a flag anyway. Alright. We'll call this first. Alright, that's our first orbital landing. And as our plaque text will say, we'll figure it out in the next episode. This has been Swordsman Gaming, signing off.